After an experiment, we calculate something called percent error. It's a measurement that we do to see if we were accurate or inaccurate based on how close we were to the true value. So percent error, here is the equation. Percent error, the measured value is the measurement that you calculate. So what you calculated during an experiment, that is your measured value. The accepted value is usually the value that is given to you, the aka true or correct value. It can be found on, let's say, a reference table. If it's not given in the question, then it's on the reference table of the accepted value. So let's take this example, number 5 and 6. Here we have, if a student measures a block of gold and determines the mass is 97.5 grams and the volume is 5 centimeters cubic, what is the density of gold? Well, we know the density of something is D equals M over V, right? We discussed that in class. We discussed that in the last video. So here we're going to start filling things in. 97.5 grams and 5 centimeters cubic. Okay, we calculate that, put it in our calculator, and we get 19.5 grams per centimeter cubic. Okay. Now, let's go to number 6. Using the density calculator for gold, symbols AU, in the previous question, determine the percent error in the student's calculation. All right. Well, now we're being asked to calculate the percent error of this calculation. So, what I'm going to do is I'm going to go back to this equation. It says percent error is equal to measured value minus accepted value over accepted value times 100. So the measured value is the calculator value, the one that I determined, right? So I'm going to put that first. So percent error is equal to measured value. Okay, well, I got that. It's 19.5 grams per centimeter cubic. You really don't need to put your units since everything's going to be in the same unit, so that's perfectly fine. Let's write it without it. Let's start over. 19.5 minus what? Okay, what is this accepted value? Well, let's go to the reference table in our case, and we are looking for AU, which is gold, and the density, the true density, the accepted density of gold. So if we go over here, we see that it's 19.3. So I'm going to put that into my accepted value. 19.3. Put it over accepted value and then multiply it by 100. 19.3 times 100. Well, I can put this in my calculator. 19.5 minus 19.3, that's going to be 0.2, divided by 19.3, and then times it by 100. I'm going to get that the percent error is 1.03, and I'm just rounding it to 3 digits in this case, and that is it. This is how you calculate percent error.